too steep to actually build, sadly. But for the next best thing, I suggest a vacation to the Hawaiian island of Maui. The shallowest slope at which a bike will still roll steadily forward is determined by the bike's coefficient of rolling resistance. In fact, the formula for this minimum slope, measured in terms of vertical drop over horizontal distance, is incredibly simple. The shallowest slope at which a bike will still roll steadily forward is determined by the bike's coefficient of rolling resistance. In fact, the formula for this minimum slope, measured in terms of vertical drop over horizontal distance, is incredibly simple. Slope equals coefficient of friction, 1, is a handy general rule in physics. The coefficient of friction between an object on a surface is just the shallowest slope at which the object slides. 2. For a nice bike under good conditions, the coefficient of rolling resistance can get as low as 0.002 or 1/500. 3. That means that to travel 500 miles horizontally, you'll need a vertical drop of at least 1 mile. To travel the roughly 2,500 miles from New York to LA, you need to start off at least 5 miles up, higher than North America's highest mountain. I suggest bringing oxygen tanks. But be warned, the trip could take a while. A bike's rolling resistance mainly comes from the way the tire for 5/6 deforms as it rolls, and it doesn't depend that much on how fast you're going. Air resistance, on the other hand, increases as you speed up, and under most conditions is the main drag force acting on a moving bike. To figure out how fast a bike will coast on a downhill slope, you need to calculate the point at which air resistance balances out the forward pull from gravity. At that point, the bike will stop accelerating. We can do that by using the formula for air resistance. V is the speed of the bike, CR and CD are the coefficients of rolling resistance and air drag, theta is the slope angle, G is the acceleration of gravity, M is the mass of the bike and rider, A is the frontal area of the bike and rider, and rho is the density of air. For a very shallow slope of 0.2 degrees or 0.3 degrees, the bike would barely roll, and its top speed would be slower than a walking pace. You would need to add an extra few tenths of a degree to get the speed high enough to balance comfortably, and this would make the LA end of the slope even higher than the already implausible 5 miles. But still, bicycles are pretty impressive coasting machines. 7 skis, which are pretty good at sliding, actually have a coefficient of friction about 10 times higher than a bike's rolling resistance. To ski from LA to New York, a skier would need to start off 10 times higher than a bike to make the same trip. Instead of the top of a mountain, they would need to start from near the edge of space. Not only is there no way to build a slope that tall, but ice isn't even stable at those low temperatures, so there'd be nothing to slide on. In practice, the longest horizontal distance you could travel on a bike with an ideal ramp is probably not more than a couple hundred miles, and that would require ideal conditions. In the real world, the longest such trip might, 8, be the Halakala downhill bike ride, which allows you to take a 35-mile trip from near the 10,000-foot summit all the way down to sea level with virtually no pedaling required. And if you can't make it to Maui yourself, you can at least enjoy the video search results for Bicycle into Water,